Alright, so I'm going to go ahead and get started with this final submission. Currently there in the attractor mode, the things that are missing is the mute of the sounds is not implemented, and there is no high score system implemented. So currently on the attractor mode there is no HUD. But there is input. There is an attractor input that does move the player around, and there is a game manager that lets you pick between 1-player mode and 2-player mode. So I'm gonna go ahead and run and show the gameplay that all the entities spawn in, and that additionally everything works as it's supposed to. That there is a full game loop. This is the attractor mode. It starts off in the attractor mode. I'll go ahead and press 1 to start 1-player mode. There we go. I'll go ahead and die so that the centipede can reset. There, it's reset. Looks nice now. There we go. And the last centipede, there we go. There's a new wave. This is wave 2. And then it resets the wave. This is the final life. I believe so. No. Yep, and there it is. So it doesn't exactly go back into attractor mode. It just creates a new attractor input, and then just if it's in that particular mode, it just keeps playing until there is till you close out. So yeah, there's no high score currently implemented. And then I'll show player 2 mode very quickly. So this is 2-player mode. I'll let my player die, and then there's player 2, and it updates the score for player 2. And then switches back to player 1, updates their score, so that is correctly implemented. Here's the switch back. And then switch back, and I believe this is the final life for either. No, this is the final life for player 2, and now we're back to player 1. And this is their final life, and then it goes back to attractor. Alright, so I'll show the various implementations for everything. Here are the scenes. This is where it handles the scene for the attractor. It is a scene, it is a public scene. So is the splash, which is technically the player 1-player mode, and then here's the scene for the 2-player mode. The game manager handles all the swapping between the scenes. And here is the input controller that handles for all the input for the player. This is for the attractor input. This is the base class. And here is the keyboard input that actually calls the functions for the specific pointer of the player, which is a blaster pointer. I'll show the blaster. Blaster then takes in the input controller, and then it sets it, and then it passes in itself to the input, so that way it can keep track of the player. Right here it calls the input controller update, so whatever the update is being used for whatever particular input, like the attractor input or the keyboard input, this is the function that's called for that. Processing the score for the player, And here, this is part of the observer pattern that is created with the bullet. This is loaded is to check the change of the state of the bullet if it's destroyed or not. So that's where this reload comes into play. It is the player is passed into the bullet, so that way the bullet lets the player know that, hey, I've been destroyed, and then here you can now reload, and it creates it recycles a bullet. Centipede has a base class. The base class has all its needs. It has the get next, the get previous for the linked list that is created for keeping track of the whole centipede. There's a base split that does nothing. There's a change head that does nothing, but it does stuff in both the head and the body. It has its set previous and next, and its states for the finite state machine. Here are its the various variables that are used between the two, the head and the body. Here in the head, it's collisions with the blaster, with the bullet. It's updating the animation for when it's moving in its various directions. Cascading here the moves, setting the state for the head to getting the next state, and then it's very similarly here in the body that it cascades the setting of the state to its previous. So it's setting its previous state to the state that is currently inside of this current body. Each object has its own factory, its own object pools that were essentially given to us through the demo. Right here in the object pool, it's kept in a stack. The factory then returns a pointer for whatever implementation you use. In here, it handles the score for this particular for each particular body. So it gets the score command, and then it processes the score whenever it's destroyed. Right here, whenever the death is reported inside of the body down here. Here, it reports the death, and then it sends the score over to the score manager. Then here is the finite state machine for the centipede. It has the basic moves, states, the different implementations for this. It derives from the move state. Move left and downward, move right and downward, turn switch to left, turn down, switch to right, turn up, switch to left, turn up, switch to right. And those are the movements that are handled in the state here in the body, and as well as the head. The body simply just cascades its state to the previous one, so that way it follows. And then here inside of the flea, as well, this one also has a link to the sound manager, and the head does as well. It has a sound that here it calls a command to the sound, and then it sends the sound, processes the sound, and then another one that reports its death so that it can be updated in the score manager. I was beginning to implement the spawners for each particular critter, but I decided against it because when I was strapped for time, so I left everything here inside of my critter manager. The alarms for everything is in here. Everything that is created for the waves is in here. Here it's calling the factories for the spider and for the flea as well, and for the scorpion, and as well as creating the whole centipede in here, and it has it in a container of a list. So whenever it's ready to wipe, it wipes a list that has all the critters that are on screen. So if there's a spider on screen, if there's a scorpion on screen, or if there's a flea on screen, and it's inside of this list, it marks it for destroy, and then it pops it so that way at the start of the wave, the list is empty, so that way it can just continue to re-add. And this This critter manager also has various removes for various elements. Like when a head is destroyed, it finds the element and it removes that head. And then when the entire centipede is empty, it updates the wave, so that way it moves from wave 1 over to wave 2 and so on. And then, additionally, it removes the body from that specific element and that specific critter from that element. These functions are to reset the centipede. It just resets it, just spawns it to whatever the current wave centipede length is, so the data that is being passed in from the file. And here is a function that just resets everything. It wipes it first, and then it relaunches the wave. So I'll show the wave manager then that everything is being passed in. This is for the hash table. So that way, when it's reading whatever in the string that's being passed in, and if it equals whatever this string is, it just enumerates it, and then runs through this switch, checking the various asserts, making sure it's within a reason, and then it closes the file. So I will show the player manager next and how that handles everything for the different modes. Just a constructor setting its pointer to null, and then when a player is created, it just calls the blaster factory. It passes in the input that's being passed in when the scene is being created, and then sets the current player to this pointer, and then the index is incremented. Then the current mode is set to whatever is being passed in, the number that's being passed in. If it's a one-player mode, it increments the index. Otherwise, it'll just, if it's in the attractor mode, it will continue to keep responding, so it can keep playing. Because if this isn't done, it'll treat the player inside of the attractor as if it was player 1. So here, continuing, you have a method that sets the player depending on whichever player it is. It then calls to the HUD manager to compute that score for that player. Here, if the lives are 0, it just resets the movement back to the attractor, but it does not switch it back to the attractor scene, so it still stays within this scene. And then this is just to calling the grid manager to regenerate the whole grid. It decreases the number of lives, and then it checks if it's player 1 or player 2, and then it computes the lives for that specific player. It resets the wave, and then it swaps the grid, and then swaps the player. And right here, if it's the attractor mode, it just resets the wave, regens, keeps the player lives at 3, and then it just keeps respawning until you close out the game, whenever you might want to close out the game. This is the swap right here, the mode, and then getting the current player that is being called inside of the bullet. And then the player manager has this struct where it has all its data, its lives, the current player number, the current wave, its score, the blaster pointer, and the grid to, or the pointer to its grid. Excuse me. Let me see, the HUD. Everything is linked into here into the HUD manager. The glyphs have their factory and an object pool. Manager handles everything. There's a string printing out the display and then pushing it into the lists right here for everything, the score, the lives for each subsequent player, and the high score. Setting the current high score to a pretty high number so that way the player has a goal to reach. The font, which is essentially what was given in the demo, the only addition was this particular symbol right here. And then the sprite sheet, again, the same thing. And then I'll run through pretty much these grid objects, which is just the mushroom. It derives from a grid cell. The grid cell is then handled here with the grid. It's just a base class, and then everything for the grid is handled here in the grid manager, calling for all its various functions. Right here, setting up each player grid to spawning to a new grid, getting the grid, spawning the mushrooms here in the spawn grid, which is right here at the top. Just randomizes locations for that. And then each function for the current grid is just clearing the grid, either converting it to a grid unit to a float, or a float to a grid unit, checking a bool check for checking for grid position. This particular function is called in the Scorpion, so that the Scorpion can check if there is a mushroom there. And then also here's the swap grid and inspect. This inspect is used in the centipede inside of the finite state machine. And then here is a convert to poison mushroom for the Scorpion. When it's checking for that particular position, it just spawns it in that position. And then this is a check if poisoned, another bool check. And here are explosions for each. Well, this is the base explosion for the critters. For the flea, the flea and the scorpion and the spider, they each call it right here. And down here, right here, calls it. And then here is the function calls to critter manager to letting know that this thing has been destroyed, so to remove it from the list. Same thing with the spider down here. Just calls it and then resets the spider and removes it. And additionally, here for the flea. And then I believe that covers mostly everything. Oh, right, the commands. I did not cover the commands. The commands, they have this base class. Each one has their own base. There's the command score by distance, command score value, and then the score manager that handles it. Each score manager creates these new instances right in the constructor, so that way that the deletion is handled here in the score manager. Adding the score, so that way it calls the player manager, setting the score, player value. And then here's the sound manager. It has the base command sound looping for sounds that loop, like the centipede or the spider or the scorpion. Pausing, this was to help with muting in the attractor mode, but I did not get that finished. Here is the sound manager, and much like the score manager, it handles everything, the creation of everything here in the constructor, and again deletes it in the destructor. Down here, everything is gone, it's destroyed. And yeah, so that pretty much covers everything. The HUD manager was the way for the flyweight. Each sound and score manager handled for the command. A lot of my managers for everything are singletons. And then I've also here implemented the factories to the specifications that it recycles. And as well as having all the elements for the game, the entities created. So there is a blaster factory for whenever the player is destroyed. And then there's a bullet factory that the bullet again handles right here the observer pattern, and as well as all subsequent critters having their game object class, their factory, their object pool. And yes, that is my current and final implementation of the game. Again, to list off the things that are missing, the things that I wish I would have been able to get in had I handled my time a little bit better, was I would have wished to have the mute implemented for the attractor mode. I wish I would have had the high score implemented. That's a big one that I'm missing. I feel like if I would have handled my time better, I definitely could have had that in. But for the time being, I'm currently happy with all the features that I've been able to implement. And as some other things that might be missing is, again, swapping back to the attractor mode from the player manager once the player loses all its lives. And then additionally, I wish I would have fixed some of the bugs for the centipede, because when it first spawns, the centipede looks great. It looks like it's how it's supposed to, but then once the player dies or swaps scenes, the centipede kind of crumples up and just looks deformed. So those are some of the things that I wish I would have fixed or had fixed by the end of the quarter, but I was a little poor with my time management. But yes, this is everything that I have, and this was the final sprint.